All right. Well,
So,
yeah, go for it. I don't think I have any reminders. I think
thanks.
people have been saying the same thing. So, this will be recorded. Thank you for joining the session with John Weirs. And as you all know, this will be posted to the NAWI community website eventually after the event. And take it away, John.
All right, thanks, Kelly. I am John Weirs, the National Renewable Energy Laboratory, and I am a data scientist at NREL and the lead architect on NAWI's Water Dams Data Management Portal. I'm going to be talking to you today about interactive data sharing and collaboration, specifically some of the challenges associated with data collaboration and sharing, and some of the benefits. And so my goal today is to have you all leave here excited about the prospect of sharing data and information and aware of some of the challenges and some of the work that we're doing to overcome those challenges. So if you were at the NAWI DOE peer review, or if you've heard me speak before, some of this will be a little bit of a repeat, but for the most part, we're going to take a deeper dive into the world of open data and specifically the prospects of sharing raw data. And I have some really fun stories to share with you all, so I think you'll enjoy them. We're going to have an interactive Jamboard session in the middle just to share some of the challenges we've all faced with our own data collaboration efforts and see what discussions arrive from that. And then we'll wrap up with some cool innovations in the open data space for NAWI's Water Dams Data Management Portal. So that's where we're headed. Just in case there's somebody on this call that's not familiar with water dams, I'm going to do a very brief overview, but I promise I'll limit that to one slide, this slide. So NAWI's Water Dams is our data analysis and management system. The system as we've designed it is actually two separate but integrated tools. We have the Data Foundry, which is our secure collaboration space for teams to organize and share resources. I kind of call it a secure sandbox where people can collaborate, work together on things. Water Dams is our public-facing repository and data dissemination portal. And that's where all the public data from NAWI-related research and development efforts are stored. That's where they're released from and essentially published from. And for the majority of this conversation, we're going to be talking about that second portal, but both of them are key pieces of the system as we look to overcome the challenges of data sharing. Some key contacts on the Water Dams team: myself, John Weirs. I'm your primary point of contact for any questions related to the Data Foundry or Water Dams, and some other people you may hear from as you're submitting data or using the data platform. You may interact with some of our data curators who work to help ensure the quality of data on water dams, or David Rager, who's our cloud expert, who occasionally comes in to assist people with large data migrations and moving things from sites to cloud and vice versa. So that's Water Dams in a nutshell. So let's get started. Let's talk about open data. You may not know it, but we are right now living through the dawn of the digital age. There's a decent consortium of scientists like myself that believe that many years from now, we will look back on the early 2000s as the official digital age. Just like we had the Iron Age and the Industrial Revolution, we're seeing a massive change. And this comes from some researchers, Lindemann et al., that noticed that 2002 was essentially the turning point when we crossed the line and more than 50% of the information in the world, we're talking every book, every movie, every stone tablet that's ever been etched into, 50% of the information in the world was stored digitally after the year 2022. I really like this graphic down here because it shows just how much that storage has evolved too. Those of you that are my age or older will remember the age of pocket calculators and the time when those smart calculators, the TI-86 and these other tools actually housed a sizable percentage of the digital information and even outpaced personal computers for a while, with video game consoles taking up a larger chunk. And then of course, servers, mainframes, and what we consider research computing facilities being one of the smaller slices. By 2007, that had switched, with personal computers being 66%, of information in the world, and of course pocket calculators just disappearing. The landscape's changed quite a bit just in the last 2 decades. Where are we at the end of this report, which I'm pulling this from a 2007 report, 276 billion gigabytes of information estimated. Estimating the amount of information in the world is getting harder and harder. IBM had a report in 2012 where they mentioned that every day we're creating 2.5 quintillion bytes of data. So much to say that 90% of the information in the world today, as in 2012, had been created just in the last 2 years alone. And of course, this has grown exponentially since then, as evidenced by the graph on the previous slide. Now we have single research institutions that are collecting 2.5 quintillion bytes of data and storing it, and some that are working to make that much data available online in open formats. We have innovative corporate data strategies. We're seeing corporations playing in the big data space that wouldn't normally play in that space. Retailers, companies like Target, have notoriously famous data scientists working for them, and massive arrays of data. So it's not just national labs and other research institutions. Changes in research data paradigms themselves, like data lakes and strategic data partnerships like data trusts, have been created. And we're going to talk a little bit more about data lakes later. But there's a growing need for data sharing best practices to evolve, to keep up with the times. And so that's a lot about what we're going to be talking about today. And so that kind of sets the landscape. And I want to talk to you about the value of sharing data. This is really why water dams exist. If you trace it all the way back to some of the data management platforms that NREL has managed over the last decade, these are the platforms on which water dams was built upon. Those platforms got their start from a 2011 directive from the Department of Energy. It really actually initiated from a White House memo on federal agencies sharing data. But in 2011, the Department of Energy included this line in their strategic plan, and I really love it. The line, of course, success should be measured not when a project is completed or an experiment concluded, but when scientific and technical information is disseminated. I think that's a really eloquent way of saying that we can have the greatest invention in the world. NAWI researchers can solve all of our energy water problems, but if we don't tell anyone about it, it has no value. Another way of saying that is that data locked in a desk drawer is a wasted resource. That's not just an analogy. This is actually part of water dam's origin story. So the geothermal data repository, which I'll reference later, a DOE data repository that was a precursor to the underlying tool that powers water dams, was originally started out of a risk mitigation studies that was done by Deloitte. And one of the risks they identified in their study was that critical research and development data for that particular industry was being lost. It was being regarded as proprietary, and it would be put on a hard drive, locked in a desk drawer. Certain individuals would retire or move on, and the data would be lost. Or it would be put into a moratorium and protected for 2 to 5 years as part of a collaborative research agreement or other things to safeguard proprietary interests of commercial partners. However, at the time, and I think this has stabilized a bit since then, Department of Energy technical monitors, many of them were on 2-year rotations and would switch over. And so there was this risk of research and development activities critical to the advancement of our nation's energy and water space, critical to missions like NAWI's, were essentially being funded, put on a shelf somewhere or in a drawer somewhere, and kind of forgotten about because they were protected by these collaborative research agreements. They were protected by other proprietary interests. And a year or two later, a new regime of project managers, a new departmental agency would come along and say, you know, we should do the same thing. And they would fund the same research again, this time awarding it to a different organization. And there was a lot of duplication of effort. And there was a lot of lost fruits from those efforts, either lost to various desk drawers or to competing organizations, et cetera. So by making our data open and available, we can actually help protect the Department of Energy's investment, research and development, but we can also extract value from it. And that's the piece I'm going to focus on for this, is how can you put your data to work for you? I'll show you some success stories on how getting word out there about your data, sharing it with colleagues, advertising it to the scientific community can actually help advance innovation and accelerate collaboration, and can help you create new business partnerships and opportunities for yourself and your colleagues, and that can actually help your research move further. So to some, it's a no-brainer. Yeah, of course. To others, it's a little bit counterintuitive. And so I'm gonna dive into a little bit about water dams and how we're structured to help disseminate this information and some of the value water dams is providing to the NAWI community. And then I'm going to share some success stories on what data sharing and true openness can actually do. And then I've got some pretty fun stories, so hope you stay tuned. All right, so what is water dams doing in this space? Well, water dams has actually been built from the ground up to disseminate and share information. It really has been designed to reach a broad scientific audience. And this network diagram on the right is the network of data sharing partners, just a sampling of them. Actually, it doesn't include all of them. I think there's over 25 data sharing partners in all that I'm aware of. And then some of these partners then federate on to other organizations too. So the actual sphere of influence is larger than even I'm aware of. But this is to say that every data submission that gets put on water dams is automatically disseminated. We call it federated because we're federating the metadata catalog, but it's disseminated to all of these data sharing partners. It shows up in the Open Energy Data Initiative. It shows up on data.gov. It shows up in Google's dataset search, which is then linked to Google Scholar. And so there's all these benefits to publishing data on water dams. And it really is analogous to publishing in multiple places simultaneously. And so one of the connections that's made automatically is the Department of Energy's Office of Science and Technical Information, or OSTI. From there, you can receive a DOI, or a digital object identifier, for your data set. It gets automatically added in the Department of Energy's Data Explorer, but also that's transmitted then to Thomson Reuters that generates a mini press release for that data. So there's all this automated outreach happening when a data set on water dams is published, and it can be very valuable to getting the word out about your researchers, about the research and development activities that NAWI is doing, about the work that you're doing, and can really help not only advertise the work you're doing, but in a way protects it, because now your name is associated with this work on dozens and dozens of systems. Many of these systems encourage the proper citation of data. Water Dams itself has this citation format screenshot at the bottom of every data submission, or we call them data landing pages. Every data set has this at the bottom of it, where users can just pick their preferred format, copy the citation, and include it in their reports. This is one of our missions, is we're really trying to promote the proper citation of data. Everyone's keen to quickly cite the journals and articles that they read or that led to their research efforts. But we want to start citing data sets as well, so that we can develop that audit trail, that scientific posterity trail for data inclusion as well. And of course, you'll see authors' names included in there. Water Dam supports the concept of data authors. Anyone that helps create, collect, or manipulate or analyze a data set is welcome to be included as an author. And then these authors travel with the metadata record to all our data sharing partners, including Google Data Search and Google Scholar. And so we can already see some successful data citations of water dams helping authors improve their scores on Google Scholar. So that's pretty exciting too. Another way water dams helps protect your research is that we do still support moratoriums on information. So if data are subject to some sort of collaborative agreement or moratorium, users can simply check that box. And since we're sharing screens, I might as well just show you in real time. I were to come here and submit data, you can see our metadata submission form. We've tried to keep it as simple and easy as possible. It is literally the lowest common denominator of all of the different sites that we disseminate information to. They each have their own metadata requirements. And so this is the LCD of those requirements merged together. And here's where we can add unlimited authors. And here's where we can check a moratorium and say, you know what, I don't want this data to be released until, we'll say, June 10th, 2025. And if I submit this data, it goes into a secure time release vault and will not be submitted until that date. However, the metadata for that data set is disseminated immediately, along with a note that these data will be available on that date. And this is hugely valuable. This avoids some of the conflict of interest, some of the duplication of effort I was describing earlier. This is the opposite of locking your data in a desk drawer. This is advertising to the entire scientific community, hey, this research was done and these data do actually exist. So instead of trying to do it yourself, maybe you should just contact us. And those data travel along with the contact information that's part of our metadata form. And so even if data aren't publicly available immediately, you can still get the word out in a timely manner and let others know that you're working in this space. And this is where another real value proposition comes into play. And we've had numerous researchers do just that and then be contacted by organizations saying, hey, I noticed you were working in this space and you already have some information. Let's collaborate. Let's work together on a proposal to take this to the next step, et cetera. So some good value there as well. We're also really interested, one of our other missions is trying to convince people to also put their raw data alongside their research data. Obviously, the final findings are the most exciting part, the summary findings, the reports, the data that was used to generate those reports is very valuable, but so is the raw data. And the reason for that is raw data is what we like to call reuseful. It remains free to be used in any context. So summary project data, findings at the end of a project are inherently filtered towards the goals of that project. It's a philosophical reality if you want to go down that path. But raw data is not. Raw data can be used again in unforeseen ways, and so it can be fuel for innovation. And so strongly encouraging people to submit their raw data to water dams as well in the NAWI space. And I have a really cool story that comes from my friend Ed Kearns, who at the time was the chief data officer at NOAA. And what NOAA did was they went through a large campaign a few years back to put all of their radar data on a public cloud and make it publicly available. And we're talking at the time hundreds of terabytes of raw radar data. So what NOAA does, if you're not familiar, is they take radar data and they have algorithms to scrub out the background noise. They scrub out tree reflections, ground scatter, they scrub out migrating birds, they scrub out other noise in the data, and their goal is to just get pristine cloud data, radar reflections from the clouds. This data goes into basically every weather forecast in North America, especially the contiguous US. And so NOAA had this great idea, like, let's make our raw data available. And as an aside, they partnered with some major cloud providers to do that. And then we tacked on to their model to support NAWI data in the cloud. And I'll talk about that in a little bit. So we're learning a lot of lessons from NOAA on this first venture of theirs. But what's really cool about NOAA's story is they did that. They put that data in the cloud, and grad students, data enthusiasts all over the US started playing with it. And sure enough, not much longer after it was available to the public, a grad student at a not top 5 university was able to improve upon the algorithms and publish the algorithms back to the open space, the open source space. And NOAA analyzed them, reviewed them, and realized that they were in fact an improvement. And so they adopted those new algorithms, and literally overnight, every single weather forecast in the US became more accurate. So that's a nice industry related domain example of sharing data. The common analogy there, the rising tide lifts all boats. Everyone benefited from the open sharing of information in that space, but that's not the part that gets me excited. What gets me excited is this part. A group of ornithologists came along, scrubbed out all the weather data and the ground scatter, and what was left was a high resolution 3D model of bird migrations for the entire US. So one person's trash is another person's treasure. And this is just a really cool example of how the raw data was reused in a totally different way, supporting a totally different industry, and led to innovations in multiple sectors just because it was made publicly available. So now you get to see why I get excited about this stuff and why open data is a passionate mission of mine. But there are a lot of challenges to sharing data, not just technological. You know, when it comes to the challenges to sharing data, people often think about just technological challenges, data transfer speed, storage limits, but there are also organizational challenges, policies, company rules about what can go where, non-disclosure agreements, financial challenges. You know, it's real easy to make the data work for me on my laptop, but if I truly wanted to share it with other people, there's probably a few things I have to do to make it easier to understand or universally accessible or shareable. And those things take time and money. There's also cultural challenges. There's some information is held proprietary, sometimes for good reasons, sometimes just out of tradition. And so this is where we're gonna take a pause. I've been talking for a while now and thrown a bunch at you. And so what I would like to do is to have a discussion on some of the challenges to sharing data. And so it's got a small group. We can open it up beyond that if we like, but I'm going to start by posting a Jamboard into chat, and I encourage you to click that link, and I'll give you all a few minutes to do that. And if you're not familiar with Jamboards, I think by this point most people are. It looks like this, and we're just going to come in here and say, encourage you all to just come over here. You can grab a sticky note, come up with an idea, and throw it on the board and try and put it into the right column. So I'll say data transfer costs. If I spell right, that would be helpful. And I can make as many sticky notes as I want and group them wherever. So please take a moment to pop over to the Jamboard. Let me know what challenges you've experienced with sharing data with others. It can be anecdotal, it can be highly technical, it can just be the latest gripe, the last thing that happened to you. Nice, thank you. Additional time, excellent. And here's one that was bothering me lately. Some organizations not allowed to use Google Drive. No. I'm going to put time under financial because time is money. Inconsistent data formatting. That definitely makes it hard. Yeah, consistency is key for understanding. And so that's where data standards are always really important. Too many think data is valuable. Yeah, let's put that under cultural. All right. We were both grabbing that note at the same time. data standards for sure. Does anyone, yeah, who pays for making them available? Absolutely. Has anyone encountered internal organizational challenges to releasing data? You know, some of the people I've talked to about this in the past have experienced like lengthy publication processes or having to actually get a manager to sign off on making something available to the public. Yeah, there's always concern for internal information leak, proprietary information. Absolutely. Not sure if you're all familiar with the term PII, but personally identifiable information embedded in the data, either obviously or unobviously, is usually a concern. That's something our curators work to address. When you place this data is located, I like that one. It's all over the map. How to determine the quality of the data. That's really challenging as well. These are great, good challenges. All right, I'll give it another minute in case anyone's in the middle of typing up another great one. Yeah, data quality is a challenge that we're almost constantly working to address with water dams, and it can get tricky too because it can be a little bit subjective, and especially if you have similar research projects across organizations, like we have to be very careful to make sure the quality of the data is clear to end users of the data without saying this particular research project was better than that one. And so it can get real tricky. All right, it looks like we slowed down here a little bit. These are excellent. Thank you all very much. I appreciate it. We'll circle back to these and chat about them here in a minute. But first I want to talk a little bit about some of these and how Water Dams is working to address them. So coming back to our iceberg, here's a few approaches that Water Dams has in terms of addressing some of these barriers. We don't have the answers to all of them. As I just mentioned, we're still working on data quality and trying to find ways to improve the accuracy and completeness of metadata as well, so that we get the understanding there. Financial barriers can be twofold. So I'll start there and I'll kind of jump around. One of the things we didn't have on our Jamboard was the cost of accessing data. Not all data sets are free. Some of them cost a tremendous amount of money. And so one of the things that's really easy for us to do from the NAWI organization perspective is make sure that access to our data is free and universal. And one of the other things we've done very recently is integrated Water Dams with the Open Energy Data Initiative. And I'll be talking about that on the next slide. But one of the advantages it does is provide free access to big data in the cloud. And that's actually really important. So just a little plug for the reveal a couple of minutes from now. But by moving a lot of these data to the cloud, by adopting a curation team, we have a team of curators that reviews every data submission that go through, first of all, to make sure that no PII data are accidentally included. So they're looking for things in the data that they think companies might not want to expose. And so they're one last check for the data submitters to make sure that everything you meant to submit is there and nothing you didn't mean to submit is there. Scrubbing out any references to personal identifiable information beyond public contact information. And really making sure that there's complete context available for people to actually understand and use the data properly. It's one thing to just download data set and use it, but if you're not aware of the assumptions or the caveats that are supposed to go along with it, then you may not be using those data responsibly. And so that's where our curators come in. They will often reach back to submitters and ask them for additional information. Say, hey, could you provide an explanation of this piece of the data or that? It's not to ask for proof. They're really looking for, like we like to say, sort of anomaly detection. If we notice there's a missing day, for example, we might say, hey, was this file just missing? Did you forget to upload it? Or should we add a note here saying, by the way, the experiment wasn't running on this particular day, and that's why it's all zeros for day 5 or whatever. And knowing that is very important to the end user for the contextual information of understanding whether a 0 is a true measurement of the value 0, or somebody tripped over a cord and the device got unplugged momentarily. We also, cultural is a really challenging one for us too. One of the ways we're doing is trying to change the research paradigm by enabling more cloud-based computing, and talk about that in a moment. But overcoming the idea of data being proprietary, it really takes champions in each organization. So we've been doing this for a while. We have good examples. I'm hoping that some of my stories today will be examples that you all can take back to your organizations and use to help champion the release of data and to put your data to work for you. But presentations like this are one of the ways we're combating cultural barriers to sharing data. In terms of data transfer speeds and universal access, we're really excited to announce our partnership with cloud-based data lakes. So Water DAMS has recently been integrated with ODI, the Open Energy Data Initiative. This is that initiative that's building upon the success of Amazon that we talked about earlier. It's a partnership between NREL, the Department of Energy, Amazon, Microsoft, and Google to provide universal cloud access to big data in the cloud. And it's kind of revolutionary. So if you were working with hundreds of terabytes of data in the past, you would have to put them on hard drives and ship them from lab to lab, or you have to use Globus, and it takes days, sometimes even weeks, to transfer these files. And you end up with this situation where the files then have to be loaded into the other organization's supercomputer, and it probably uses a different format. So they have to go through some sort of translation. All that costs time and money. And at the end of it, you have different versions of your data in different locations, often in different formats, which leads to inconsistency and make collaborating even harder. So a data lake is just all the data in the cloud in one centrally located, centrally accessible place. So it's the same data set, the same format, and it really cuts down on transfer time, lets us spend more time and money on actual research and addressing the challenging and interesting questions, and less time on copying and translating data sets. But the really cool value proposition is that it provides universal equal access to big data. So one of the things NREL realized a few years ago is that with our big data sets, NREL has NSRDB, it's like 90 terabytes. The WIN toolkit's like 600 terabytes. Our OD initiative now has over 1.4 petabytes of data in the cloud, really accessible. And one of the things we realized a couple of years ago is that prior to OD, we were inadvertently limiting our ability to collaborate to only those organizations that had supercomputers or had mass data storage capabilities. So national labs, large universities, Fortune 500 companies. And by making these data universally accessible in the cloud, by allowing NAWI information and research to be put into a cloud-based data lake, We can now open the doors for collaboration to smaller universities, to high schools, to startup companies, to underprivileged communities, and other sources of innovation. And that's been really exciting. We've had a couple of fun success stories coming from that. But on the topic of success stories, I want to tell you about another one. So we talked, as we look to wrap this up, talking about the NOAA story and how radars led to the quintessential ornithology database. We have, from the NAWI water dam sister site, the geothermal data repository, our own example of that, which is really cool. And so one of the teams, and this is in the geothermal space, and someday I hope to have an example just like this for water dams and for the NAWI space, so stay tuned for that. But in the geothermal space, one of the challenges with drilling for geothermal energy is that, unlike oil and gas drilling, you're often drilling to hotter, deeper rock. I don't know how much you all know about geothermal energy. Some of the equipment, some of the cutting edge oil and gas drilling equipment fails at those higher temperatures, especially when you get down to resources that are pushing 250, 300 degrees Celsius. So what happens is, well, we just need more temperature resilient equipment. And so one of the things the Department of Energy funded was an evaluation of high temperature commercial off-the-shelf flash memory modules for use in geothermal drilling. So how can we get geothermal sensor and electronics packages down in the holes and actually measure things without our measurement devices catching fire and burning up, right? That was the challenge. And the research evaluated sort of things very successful, laying the foundation for future research and developing additional technologies in the geothermal space. But what we noticed from this sister site of water dams was that this data submission quickly rose to the top. Now the #2 most downloaded data set in all of our geothermal data repositories. And the reason for that is that it's actually the raw data of the flash memory module tests was immensely reuseful, not just for geothermal. There are lots of industries that are interested in high temperature electronics. We saw downloads from EV manufacturers. We saw tons of downloads from NASA and aerospace companies. And this one data set's being used by dozens of industries across the US. And so it's a true testament to how that network of data sharing partners can actually add value. Even though the geothermal data repository is very geothermal domain specific, the raw data gets shared and picked up by other data repositories around, just like publications, and gets republished. And now that particular team has more work than they can handle, because they're getting calls from NASA and the Department of Defense and Tesla and all these other organizations to continue their research in high temperature electronics. So just a really fun success story of how submitting to a data system like water dams and getting the word out about your data and sharing the raw data from experiments can actually help put your data to work for you, and can actually help advance your own research initiatives. And so here's just a couple guiding principles in closing to help you put your data to work for you. One is to make sure you make it useful. You got to provide the context necessary for understanding. I talked about that a lot in data curation. We like to talk about things in terms of a complete data package, and that involves making sure they have the understanding. Example of a complete data package would be the raw data, the input data, and the output data, and a link to the paper that explains the whole process. So you have all the resources there to fully understand what's happening in there, instead of just an ambiguous CSV file. #2, you got to make it accessible. We got to eliminate any barriers to download or use. Everything on water dams can be downloaded without an account, without charge. We're striving for free and open data sets. But like I said, we do support proprietary data in a secure vault. We make the metadata available to the public because there's an intrinsic value in making the public aware that data exists, even if they can't have access to it yet. And we got to tell a story that ties into that complete data package. The metadata associated with the data, the description has to be enough of a comprehensive story to empower somebody to use the data properly and to truly understand it. We don't want people to misuse the data because of a lack of metadata, for example. So that is my presentation. With that, I'll say thank you and open it up for questions. Well, thank you for sticking with me. I appreciate it, time, and I really appreciate the ideas for these challenges. We'll be publishing these along with the slide deck as part of the spring meeting, and in future presentations, I'll be adding these to my list of things water dams needs to address. So thank you.
Thanks so much, John. For those that are still on the line, please head back to the main session for closing remarks.